Good afternoon, everyone. Our topic for today's presentation is automatic wheelchair control based on eye gaze recognition. Our batch code is 9, and I am Syed Abdul Mateen.
I'm Nisha.
I'm Aishwarya.
I'm Nabila.
And our project is under the guidance of Professor Santoshi. Now, Nisha will explain you the introduction about our project.
Hello, I'm going to be explaining about introduction, the motivation for choosing our problem, and also how we derive the problem from various sources. So let's begin with the introduction. As we all know, there has been immense amount of advances in the field of locomotion. From the invention of bicycles to trains and planes, humans have explored every nook and corner to improve transportation. In the present era we live in, vast progress has been made in existing transport system, from innovations such as self-driving cars by companies like Waymo and Tesla, gesture-based vehicles, hoverboards, and smart cities. Many methods go to vain when it comes to differently abled people, although there are numerous facilities to accommodate them. According to the global statistics, nearly 175 million people are wheelchair bound, and we know that a wheelchair has been in existence for a very long time, nearly 5,520 years or so, but there is no significant improvement or economically viable solution in transforming them to benefit the common people. Sure, there are additional setups and customizations, but these are very expensive for an average citizen, and in addition to this, installing these setups alone will cost more. Disabilities are caused by paralysis, Parkinson's disease, spinal cord injuries, and accidents, and they majorly affect a person's day to day activities. And in these cases, there's only one option for an individual to move around, and it is to have a caretaker or a nurse to assist them at all times in moving around, making them feel completely at loss of independence. And we believe that a simple transformation, controlling a wheelchair, can be achieved by integrating machine learning, image processing, and IoT techniques to bring together a system which will be not only convenient and easy to use, but also highly affordable and accessible to everyone. One in seven people are affected by disability, and 75 million people are reported to have mobile disabilities, that is problem with walking, climbing, and even standing, and hence they compulsorily need the wheelchairs. We come across people with motor disorders every now and then in our daily lives also, and these people need special care and attention because they're fully dependent on another person to move around, and this makes them feel restricted. And it was also found that people with mobile disorders were more likely to be undereducated, living alone, middle aged, or elderly, and living in poverty. And it was also reported that around 60% to 70% of the people were frequently depressed or anxious and also felt isolated. They feel like a burden on others due to their restricted lifestyle, which put more pressure on their mind and deteriorated their health. Their mental and emotional well-being is also compromised. As a result, we decided to come up with a highly cost-effective method that uses machine learning, image processing, and IoT to not only ease the transportation but also help them achieve independence. And we believe that commercially viable solutions will be available soon, and we will be providing the solution to the people with this will be the beginning of a new change which will make a difference in how we treat and help the disabled people, and also contribute a little bit towards betterment of remote healthcare. Coming to the problem sources, we reviewed many papers, including and one such IEEE paper, as shown in the PPT, is as follows, where the author managed to take a picture of the eye and they segmented it and processed it. And another type of approach that is used in IEEE 2018 publication was made use of pupil fitting, that is relying on shape and variation of the pupil and also on the position of the pupil to enhance pupil performance and detection. And the third paper, the authors entirely came up with a new method to effectively capture the iris and segmenting it to obtain signals, which was in turn used to control wheelchair motion. And other sources were from ACM Digital Library about wheelchair motion control guides, which involved methods such as voice commands, head gesture based, and a robotic wheelchair that could move along the caretaker as they move. And we also researched about articles involving mobility difficulties from various sources like Journal of General Internal Medicine and Springer. We also came across a blog called Have a Wheelchair Will Travel, which was dedicated to helping people who are wheelchair bound to reach their dream destinations by providing them with complete assistance in regard to transportation. And these are some of the sources we derived our problem from. Now Aishwarya will continue with the explanation. Thank you.
Now I will explain some of the existing system. One such existing system is conventional wheelchair, which is operated manually, and they also need an individual to assist a patient in moving around, which will result in complete loss of independence. And EOG controlled wheelchair, which involves electrode, where electrode are those are placed around the eye, and that will make very uncomfortable for patients, and also it is inconvenient. And voice recognition technique cannot be used by people with speaking disability, and recognition rate of voice for the same person are acceptable, but it cannot be applicable in crowded place due to number of voices. And also there is a head motion control wheelchair where it operates with head movements, which results in inconvenience for patient who struggles to move their head. And electric wheelchair consists of a standard power where you will need to be conscious of power usage, and it is also required of use of joystick, which is not viable for completely paralyzed people. Now Matin will explain further.
Keeping in mind of all the drawbacks of existing systems explained by Aishwarya, we develop a wheelchair which would be based on eye gaze technology. We chose eye gaze technology as a solution over existing systems drawbacks as even for paralyzed person it has minimal effect over their eyes. Eye gaze technology is an emerging technology in today's world where a person can use a computer or a smartphone by pointing through his eyes as a mouse. Eye gaze is done in three ways where three different parts of an eye is focused, which are sclera, pupil or iris. In our system, we are focusing on iris. We will use machine learning and image processing algorithms for the detection of iris and IoT for the hardware setup over the wheelchair. Our system would be able to detect the iris of the person, and after it detects the iris, its movement will be tracked and processed, based on which the movement of based on the movement of iris, our wheelchair would move. For example, if the person moves his eyes towards the right direction, the wheelchair should be able to move towards the right, which would make the person who is paralyzed or disabled to travel or move independently. Objectives will be explained by Nabila.
The main objectives to choose this project are to develop a wheelchair which can be controlled just by the movement of eyes for the mobility of the physically disabled people. A project will be more convenient and easy to use by people because there is no any bulky physical attachments attached to any part of their body. In our project, we are using a camera which will be mounted on the person's cap, which will first detect the iris using image processing, and then iris is tracked using the video processing technology. Then next, this image processing output will be converted into domain format and sent to Arduino Uno microcontroller, which will be the input for the wheelchair. Then the wheelchair motors will move it accordingly. We are aiming to present a sample robot of a wheelchair, which will give the idea about the project. Coming to the initial pathway, first we will start with the software part. Initial pathway. First, we will start with the software part, that is the detection of iris, tracking the eye gaze and processing the gaze. Next is to decide the components required to fulfill our objectives. Then later we will integrate these components and test them accordingly. In the later part, we will decide the arrangement of components and arrange them accordingly. Next, we will set up all these components onto the wheelchair. Later, we will upload the processed gaze input taken from the software. Then finally, our automatic eye gaze based wheelchair will be ready. Thank you.